That's a little strange.
I didn't make that rule. Okay, I need you to find page 3. Okay, please find page 3.
Yeah, I bet you do. Okay. I bet you do.
Okay, so you need page 3. Trigonometric identity is page 3.
Trigonometric. Yeah. Trigonometric. That's great.
Wow, Ellen. Nothing.
She's getting to you. Hold on. She doesn't talk to me yet.
Okay, so
How was your FFP space station? I didn't realize that. Which is the highest? How much is it?
I don't actually know. It's getting me more excited.
okay, we are starting lesson 5.4 today, which I didn't write on the board. I forgot. And we are talking about sum and difference. They call them formulas. Someplace they call them identities. I don't know. So there are 6 of these that we need to write here. And we're going to talk about how to use those today. So we will be using them for finding exact values of various things, proofs, and then solving equations. So we're going to be doing a lot of things with these guys. So here is the first one.
Holy smokes. Oh, cow. Man, why don't they just down like a minute? Is there really 2 for each one?
Hmm?
Is there 2 for each one?
Look at plus, minus.
Whoa. There's literally like 60.
This is not very nice right here, but it is u plus v. It just didn't come out nice.
Guys, why did I come back?
You had the choice to not come back?
Not really. No. In theory, I could.
Oh my gosh. Keep breaking. Wait, why is the sine one sine cosine one?
Because it is. I literally, truly just, this is a formula. I did not make it up. I'm guessing it just has to do with how you put the things together. And I don't know. If you would like to see the proofs of them, they're on page 402 in your book. Okay. Nope, me neither.
Look it up why it's like that. Javon, half the stuff that comes out of your mouth doesn't make any sense. But yet you keep talking.
Yikes.
She didn't make her thing.
I didn't go
50 over?
50 over what?
The speed limit? What?
School zone?
Hello?
What?
How?
What's going on? What? What are you talking to?
Someone just said, shut up, Connor, at least I wasn't going 50 over.
What? When was I going 50 over? Who said this? Who was the one that displayed this information?
Ow. Kira, did we just hear that? Or did
I
that-
swear
someone
I just
actually
heard
said
that. Somebody said, at least I wasn't going 50 over.
I think it was
I think it was Javon.
Javon, when was I going 50 over?
Yesterday I was running from the cops for going 15 over.
Go 50 what?
15.
No.
You were running from the cops?
What?
No, they didn't have the lights on. I was evading though. I was evading and eluding.
going 15 over.
Yeah, I was going 15 over and I had one over the other going on it out.
Who were you running from the cops again?
Oh, yeah.
I wasn't running from them. They didn't have the lights on. I was eluding.
What was your metaphor? You're running from the cops just like,
I was evading and eluding.
yo, Connor.
Just like you.
There it is.
Yeah.
Okay, so
I'm not that.
Not that bad.
Ellen and Kira came back.
Dude, facts. Ellen and Kira, last Miss Douglas's class was actually like 9.
yeah, it actually was.
I literally heard the recording. You guys were really loud.
I mean, that too, but
We weren't even that bad.
Yes, I did listen.
Javon's over here partner in 30%.
No, I did not.
Hurry up,
Bro,
Javon.
It wasn't me.
Yeah, Javon,
It was
right?
literally-
Javon, right. I'll keep my task.
I got you. You can go. I'm done.
okay, thank you. All right, so we are talking about
Like you're not full of attitude.
Oh, I am, but mine's
All the time.
This is not justified.
It's
Literally
literally
all the time. Okay.
one time.
What?
I'm supposed to grab her because otherwise she just
okay. So
walked in like.
can you please be quiet? We're going to be using these formulas. Okay, make sure to keep them out because you're going to need them all day today in this class. We're going to be using these to find exact values of things that are not on the chart. Exact values of other things that are not on the chart. That's not very helpful.
Exact value of things that are on the chart.
And other things. So let's go this way. We're going to find exact values of angles that are not in the circle. Okay, so here you go. For example, we're going to find the sine, exact value, which I'm not going to write down, of 75 degrees. Okay, so you don't need your circle also. So if we're going to find the sine of 74 degrees, you have two choices in how you could potentially get it. You have two formulas you could use. You could use the sine of u plus v, or you could use the sine of u minus v. So what you need to do is figure out on your circle a way that you could get 75 degrees. 75? Yeah. So I'm thinking it's 45 and 30. That's the easiest way to get 75. Okay, so we're going to do the sine of 75 is going to be the sine of 45 plus 30. Okay, so it's not a mystery about how you get these. You literally find your angles that would add up to whatever. And that's one reason I gave you degrees, just a little bit easier. So then if you look at your formula, 45 is u and 30 is v. Okay, so now I'm going to just write down, I'm just going to replace. So we've got sine of 45, cosine of 30, plus cosine of 45, sine of 30. You guys see where I got those? Okay, it's just to make sure you know, it's this formula. So I used u plus v. That means my first one is 45, this one is 30. You could do 30 and 45. It's not going to matter because it's addition. So each of these pieces separately, right? This piece, this piece, this piece, and the last one, those are all numbers that are on the chart. Okay, so this now is not difficult. What is the sine of 45? No calculators. Levi, use circle.
45.
Sine of 45. Square root of 2 over 2. Okay? No, I said get your circle out. Okay? What's the cosine of 30?
Square root of 3 over 2.
Square root of 3 over 2. What's the cosine of 45? Square root of 2 over 2. And what's the sine of 30? 1/2. Okay? Now, what I want you to realize is each of these pieces turns into a number. So that once you do this, there's no more sines and cosines. I really love that Eli's using his calculator too. Don't use your calculator. Okay? So, when we do this, when we multiply top times top, bottom times bottom. So what's this fraction turn into? Square root of 6 over 4. Okay. What's the other one? Square root of 2 over 4. And so then a couple of things about this. This will always have a common denominator here. It should always have a common denominator there. If it doesn't, you might have made a mistake. And so then when you add them, you have, yikes. Add the top and the bottom stays the same. Okay? Add the top, the bottom stays the same. So we can multiply square roots, but we cannot add them. So you just literally add them. Square root of 6, square root of 2. Okay, that is not the square root of 8. Now, that's your final answer. You're done. That's the exact value. Now, here's the nice thing about this. This is degrees. So if you were to switch to degree mode and do the sine of 75 and then type this in, you can see if you're right or not. Like if you're taking a quiz, you can check your answers pretty easily. So square root of 6 plus square root of 2 over 4 should be the same. Okay, so it's always nice. The difference is the reason you're not using this is the square rooty one is the exact value. Okay, so that's the difference. Just be careful that you are in the correct mode, because if I give you radians, you got to be in radian mode. Let me have you try.
So, like, what's the purpose of putting into an exact value?
Sometimes you just want exact values.
But like in the real world, like
It's more accurate.
Learning how to learn Javon.
Let's go. Let me have you try cosine of 15 degrees. Cosine of 15 degrees. Okay, so your first job is to figure out what angles you're going to use that are going to get you 15. what angles you can use any angles that you want. If you stay in the first quadrant, they're all positive and it makes your life easier. So if it's possible to stay in the first quadrant, you can. What angles you want to use? Yeah. Order matters this time though, because it's going to be because you're subtracting. So our formula says subtraction, cosine u, cosine v. So cosine 45, cosine 30 plus sine 45, sine 30. Okay, so cosine 45 we already know is square root of 2 over 2. Cosine 30 is square root of 3 over 2. I think this is the same.
It's the same.
Nice. Square root of 2 over 2 and 1/2. Square root of 6 over 4, square root of 2 over 4.
Go back to your sheet, please.
This sheet.
Yeah.
Cosine.
I copied it right.
You your cosine backwards.
I didn't tell my phone.
I'm not fast.
Just like the cross
First of all, you copied that down before I got to it.
Look, he looks like Jeffrey Dahmer.
My dad looks like.
I'm
That would make
serious, yeah, they just
sense.
in glasses like
I don't have the
that.
same answer, but
I was like half asleep. You know,
Look,
like,
he was a little goofy looking in high school. He definitely aged better than high school. He's not a cutie back in high school. My dad.
Okay. Let me have you. Let's do one tangent one just so that we know what we got going on. Okay. Let's do tangent of pi over 12. Knowing that pi over 12 is pi over 4 minus pi over 6. I gotta make sure. Just a second. 3, 2. Pi over 12 is pi over 4 minus pi over 6. I'm just giving you your u and your v. This is u. This is v. Okay, so
This class sucks.
we got tangent of pi over 4 minus tangent of pi over 6 over 1 plus tangent of pi over 4 times the tangent of pi over 6. So here we go. Couple things I want to tell you about. Let's talk, what's the tangent of pi over 6?
It's
No, it's not. You didn't listen to my question. It's the tangent of pi over 6. So it's y over x. Square root of 3 is on the bottom. Right? Just keep switch flip. 1 over square root of 3. Square root of 3 over 3. Okay? So tangent of pi over 6 is square root of 3 over 3. So what's the tangent of pi over 4? That's an easy one. 1. Okay, so we've got 1 minus square root of 3 over 3 over 1 plus 1 times the square root of 3 over 3. Okay, so no.
No, just kidding.
You can't cancel anything because of the pluses and the minuses in there. So don't cancel anything here. What you have to do is come up with a common denominator. This is not difficult. First of all, what's 1 times this? The same thing. We're going to get rid of that one.
Whatever, bro.
What's the common denominator? Let's go. Common denominator on the top is 3. So your 1 turns into what? 3 over 3. This is the easiest common denominator. So when you have a 1, life is really good. Okay, this is also 3 over 3. So the top is 3 minus the square root of 3 over 3 divided by 3 plus the square root of 3 over 3. What do you got to do? Keep switch flip. So 3 minus the square root of 3 over 3 times 3 over 3 plus the square root of 3. 3's cancel. So you got 3 minus the square root of 3 over 3 plus the square root of 3. Now, I'm going to be completely real with you. We should rationalize this, which is brutal. It's not brutal. I just don't want to do it. So you can leave it. I feel like we've done enough of that already. 3 minus the square root of 3 over 3 plus the square root of 3. If you were checking this in your calculator, okay, if you were checking in your calculator, you would need to, I just lost my train of thought, sorry. You would need to change your calculator to radians or else change this to degrees. Okay, I think it's 15. Okay, so just be careful when you're checking. Now, here's what I'm going to say. This is not as likely to use. There's very little, like I can ask you for 15 and 75. There's not very many angles I can ask about because we don't have a lot of choices. I could maybe ask you for 165. There's like 8 angles I could potentially ask you about. The next one that we're going to talk about are exact values for non-circle. Okay, so this one, way more likely to be used. What?
I'm in refrigeration is in radiant mode. I'm gonna put it in radiant mode. Okay, well, never mind. I had to take it just for 1 second. Yeah, we're good.
Are we good?
I clicked radiant mode. It closed me out of the mode thing, so I was like, okay, I'm in radiant mode.
I'm
Did the
hearing you
equation.
exactly what you said.
What?
I'm hearing you.
Ellen, I'm hearing a lot of interjection.
Yeah,
At least I tried to check it. Nobody else did.
Accepted it, okay?
Alan just accepts anything that's please.
Oh, okay, come on.
It's just not how lazy you're.
That's my point.
Okay, we're going to be doing several things with this. Okay. So here we go. This is, like I was saying, this is much more likely to be something that you would see because the possibilities are limitless. So we've got sine u in the second quadrant is 3 over 5, and cosine of v in the fourth quadrant is 12 over 13. This is why we did the warm-up we did today, because it's related to this. So whoever said it was review, absolutely correct, but it's related. So the first thing when you're doing this, we are going to use many of these. We're going to use these 2 triangles for several things. So let's do all the work at the beginning, okay? So both of these require you to make a triangle. Okay, sine is 3 over 5. What's our missing side? 4. Okay, so what I would do, because we're going to use this, I would write down and you guys, because I've seen this. People can do this whole thing and they'll get it wrong because they've missed a negative. Okay, so let's fill this all the way out. What is the cosine of u then?
4/5.
Negative 4/5, because we are in
Just said this.
we're in the second quadrant.
My bad.
It's
I
all
wasn't
right.
looking at the quadrants. Hop off, you Javon.
Okay,
Lay off.
stop. How about the tangent?
I'm stuck at A's now. You guys can get this.
Negative 3/4. Okay, and we know they're negative because it's in the second quadrant. Okay, so use the triangle. That's the easiest way to get these. Tangent and cosine are both negative because we're in the second quadrant. Go ahead and do the same thing and find me the sine and the sine of v and the tangent of v in the fourth quadrant.
Holy smokes.
Yo, I might be stupid.
Last time when we took our test or our quiz on this in chapter 4, one thing that people made a mistake on is not putting the hypotenuse as c in the quadratic formula. So make sure that you're doing a squared plus 12 squared equals 13 squared so that you get your correct value for a. Okay, what's the sine of v? Okay, because this 5 over here, fourth quadrant, sine is negative. What's the tangent of v? Okay. Now, if we do these, now we have all 6 possible things we could use. This is going to make life a lot easier. And actually, I find these a lot easier than the ones from the circle because there's not square roots. You don't have to rationalize like so far anyway. Okay, so let's do the sine of u plus v. So if we use our formula, it's the sine of u times the cosine of v plus the cosine of u times the sine of v. Okay, all of these things we have on our paper already.
Whoa.
It's a lot of work.
It's not.
That makes, oh my gosh. That makes sense now. Yeah, I'm sure you guys, hold on. I understand what we're doing.
So it's gonna be, is it 7?
Okay, so sine of u, 3/5.
Oh, okay.
Cosine of v, 12/13.
I just saw a lot of V's.
uv.
I just was, yeah.
Okay, cosine of u, negative 4/5. Sine of v, negative 5/13. Now you can see this right away. It has a common denominator. Okay, if you have that common denominator, chances are that you have done it right. It's not a guarantee, but if you don't have the common denominator, you know you screwed up. So what's this fraction? The first one? 36/65. This is plus and 2 negatives, so it's still going to be plus. What? Over 65. And because these are all numbers, we can actually add them. Yep. That's a much nicer looking answer than the other one. The downside of this is there's no way to check it. Okay? It just is. Okay, so let's do tangent of u plus v. And I'm happy to tell you that this tangent is significantly easier than the other one. Okay? Because we're not dealing with roots. So tangent of u plus v is going to be tangent of u plus tangent of v over 1 minus tangent u times tangent v. So because these are all numbers, I don't have room here. There we go. Because these are all numbers, it's going to be a lot nicer. Okay, so tangent of u, negative 3 over 4, plus tangent of v, negative 5 over 12. And then we've got 1 minus tangent of u times the tangent of v. Okay, so listen, if you cannot add fractions, number one, just find a common denominator. You can do this. But if you can't, put it in your calculator. Just make sure it's a fraction. But between 4 and 12, what's the common denominator? 12. So we multiply this guy by 3. Okay, so this is a negative 9 over 12 plus negative 5 over 12. What is that?
Negative 14.
Yep, so we've got negative 14 over 12 on the top. On the bottom, okay, we multiply first. It's order of operations. So what do we got?
I don't know.
Really?
48 switch flip.
No, just a minute. You're just ahead of me. This is 15, positive 15 over 48. Okay, common denominator with the 1. 48 over 48, super easy. 33, right?
Yeah, turn line.
33 over 48. Now keep switch flip.
Oh.
Because you got fraction division.
Yep.
So negative 14 over 12 times 48 over 33. I would do this in my calculator. Just use it with fractions so it gives you a fractional answer. Because some of this mass reduces. Yep. So this is, I found this out from dealing with freshmen.
Oh, they're both 56. Coincidental. Probably. I think not.
If you put this in your calculator, so if you were to do this times 48 divided by 33, it will you please listen to me. This will return a decimal to you. Okay? So you would have to, if you want to do it that way, you have to go into math and go back to fraction. Math number 1 will turn that into a fraction for you. So there's your other option. But if you wanted to just give you a fraction, you have to start it with fraction form. So your calculator knows what you're doing. Fraction, it gives you a fraction. Okay, we will finish this lesson tomorrow. We will have homework.